Hi, Brianna. Hi, Charlie. All right. Good morning, Saad. Awesome. All right. Now we're going. Good morning, Alyssa. Sorry. Oh, that was my bad. Good morning, Alyssa. Good morning, Saad. Hello, Brianna. Hello, Charlie. Hello, Noel. I love it. I love it. I love it. Maybe someone could tell me if you hear. I'm thinking you can hear me. Good morning, Noel. Thank you. Good morning, Charlie. Thank you. Awesome. Good morning, Vivian. Awesome. And maybe someone could give me a sound or let me know if they're hearing mine. Well, oh no, you must be. Yeah, of course. Thank you. Thank you, Charlie, but I'm an idiot because obviously you heard me because, right. Okay. Yes. I mean, thank you, Alyssa. Okay. But I do appreciate it. Okay. Cool. Who else? I'm trying a different, okay. I keep still experimenting with like the view on my side, partly for the sake of the recordings, which I don't know if anybody's, sometimes the recordings are big. Okay, and did I just lose? Okay, okay, right. So who else? Oh, and there's more people. Sorry. Yeah, I'm fiddling with the view because the recordings, I don't know if anybody watched, but sometimes the recordings are really big and sometimes they're really small. And I still, after semesters and semesters, can't figure out what the factor is that drives that. Maybe you guys know. Okay. Hello. So I think I've said hello to every. Yes, Vivian, yes, Charlie, yes, Brianna, yes. Hello, Lakshmi. Oh, thank you so much for showing. Hello, Jayla. Thank you so much. Hello, Julie. God, you're all. This is like the best class. Seriously, if they're okay, I'm gonna open a portal soon. I'm way behind, as you might have told. I'm way behind you guys, and I'm aware of that, and I apologize. But so there's another one of these promises that I will eventually keep. But that is, I've got to open up a portal for like collective success, like definitely as a group. You guys are showing more video, and that's just one metric, that's just one statistic. But I want to start doing some kind of weird game theory thing where individuals get points for full group success. I guess that's called lab, actually, but that's a topic for another time. Anyway, hello, Farouk. Hello, Alyssa. I said Alyssa. Hello. I said Julie. All right. I think that's everybody that I'm saying hello to. Yes, I think that's everybody. But I really appreciate how much video and dog avatars, etc. Or okay, oh, that's not a dog. Sorry, are being shown. Okay. Oh, and there's more people. We're going to start. Again, I'm just slightly like stalling here and getting warmed up while more people come, but I'll just tuck in. I am aware that I'm very behind you guys, and I keep saying that, and I keep sort of falling more behind. I'm going to continue to blame it on holidays and family because of my culture. I'm going to totally blame it on my own culture. That's a nice twist, right? And that's not really fair or true at all, but I will catch up. The good news about me being behind you is at least it means that definitively you are not behind me. Like, that's all I can say at the moment. Everybody's doing fine in this class. Okay, I think that's one more person just connected. Oh, and another video. That's awesome. Okay. Yes, thank you. Hello, Rydia. Great to see you. Okay, so we are going to start. We're just going to, again, apologies again. I owe you guys a bunch of stuff. Most of you don't owe me anything, except maybe you're doing revisions and stuff, but I'm behind you, not the other way around. Again, that's both an apology. That's three things. That's an apology. That is also an assurance that I will catch up. You will get your work back. It's also a praise to you that you are not behind. You are doing great. You are a particularly great section. And again, maybe I say something, I'm more of a complimentary guy than an insulting guy. But again, like I have been teaching for a long time. I've been teaching since 1992. I do not tell every section that they're a very good section. I think you are a very good section so far, really. And especially, and for Zoom, even now, we've all been in Zoom school for like, I don't know, 5 semesters, something like that. And like, in that data set, I'm really pleased with what you guys are doing. So I'm going to beg your forgiveness that I'm behind you. I'm going to dive back in and start continuing to go over stuff today. We're just going to keep going over stuff like as though it's recitation. At some point, also, I will once I catch up a little bit and like get on to homework 2 and 3. And oh, and I think I never even posted homework 4, which is fine. I think that's true. I apologize, but once things get thicker, I'll also check in with you about what's going on in lab and how's it going and what are you doing and stuff. I don't think I want to do that today because I want to catch up, but believe, oh, hello, not what I meant to do. Sorry. What did I mean to do? All right. But anyway, we're going to go back to finish number line today. That's where we are. I know you didn't even get your game participations back today. I know that you will get them. Okay, but I have to switch the view here. Okay. But obviously stop me anytime with any questions, and we're nowhere near an exam or anything like that, so don't worry about that. Let me just now find where did, oh, please tell me this didn't get erased. All right, okay. So we're doing this now. All right, so we're going to go back to hopefully finishing up number line. I believe, oh, I'm going to pull it up. You can tell while I pull up number line, you can maybe remind me, even though I'm pulling it up. And my real goal today is to get finished with number line and move on to the next 2 homeworks, which have some tricky questions in them, I might have mentioned. But maybe you can remind me while I pull up number line, maybe you can remind me what question we were on. Well, or I'll tell you what I think, but you tell me. I think the last question we actually went over in number line was part 2, number 1. I believe that's, which I made much more complicated than I should have, but I believe we got an answer to part 2, number 1. And part 2, number 2, we got an answer to part 2, numbers 1 and 2. I believe that's where we stopped. So maybe if someone wants to put in the chat if that's wrong or right or something, or if you want me to back up to anything. But so I believe, in other words, I believe in the children. Well, and I'll just write down the answer. So the answer was those middle 2 seconds. Oh, right. So was this like 6? Right. Okay. So I believe. Oh, chat. Okay, I'm looking at the chat. Yes. Oh, cool. Thank you. Oh, great. Thank you, Alyssa. Thank you, Jayla. Great. Okay. I appreciate that. And that's like major points, blah, 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 and karmic points, and the quark in heavens is smiling upon you. All right. And just to be a little bit minor or a little bit technical, notice I put a tiny little plus sign next to the 6 feet in answer 2. Both of them, the answer is positive. Both of them, I could put a little plus sign or not. I don't need to be technical or anything. The reason I'm just putting a little plus sign in the 6 feet answer for number 2 is just to like gently remind us all that with the displacement question, the answer could have been negative. Like displacement could be negative, and it just happens to be positive in this case, whereas distance would always be a positive answer no matter what, right? Sorry, okay. All right, so that's okay. And just a side note, you might note, like, oh my God, sorry. I don't know if you've ever noticed. Oh. I don't know just if, I don't know if you've noticed, but so in other words, for any given question, okay, chat, I'll get to the, okay, actually, that's a great question, Lakshmi's question. That is really a terrific question, actually. And that is like major points, blah, 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 blah. Really a good question. So Lakshmi's question, I think you can read it, but it says, is displacement always negative when the object moves left? Or can we assume that when the object is moving generally in the opposite direction, it is negative? That is a really, and I hope you see the distinction she's drawing. Like, she's really asking, like, does negative refer to a specific, almost, you might say, objective direction, or does negative mean opposite? Which is a really good question, because even in math, that is kind of ambiguous. Like for example, all right, not to overplay this, but just to make it clear to everybody that really is a question going on there. Like, in math, like -4 means +4, right? Like negative quantity something means take the opposite of whatever its sign is, right? So really so sometimes that is ambiguous in math. Okay, I almost want to put, okay, wait. And then I got a just question in the direct chat, which is a good question. Also, I'll try to answer in a second, but it's private. So, okay. But on Lakshmi's question, so the fast answer is what negative literally does, maybe I want to write this, like negative does mean negative sign is what we use to mean a particular direction in physics. Like direction ends up being very, very important in the study of space and time. Negative signs are what we use for direction on any given axis, on any given line. So if the two choices in Lakshmi's question are like choice 1 or choice 2, my answer is more choice 1, direction, displacement is always negative when the object moves left. But now let me just qualify that slightly. Negative means left in this case, in this problem, because this number line was labeled that way. In other words, once we made a choice that 0 was in a certain spot, and once we chose to put the negative signs on the left, and we chose to put the positive signs on the right, then from then on in, anything that ever points left, whether it's displacement or velocity, as we're going to get to, or acceleration, as we're going to get to, or force, or electric field, if anything points left, we're going to call it negative, as long as we started off with a coordinate system that made that decision. Just to be clear, this is one of the reasons that the diagram is so important. And in fact, this is going to get me to answer the second question that's in the chat. One of the reasons the diagram is so important is there's no objective rule in physics. There is not an objective law in physics or in space that left always has to be negative, honestly, nor is there a rule. For example, and this is going to become very important, oftentimes we'll say if our axis is turned this way, we'll often say that down is negative and up is positive. But we will equally often, believe it or not, we will often also choose to say that up is negative and down is positive. There will be times when we're going to say that right is negative and left is positive, but we have to make that, so it's up to our decision. And this is actually the purpose of what that third homework train of thought is all about. The coordinate systems are something we choose, and we make a choice, but we have no choice but to make that choice. Like we're going to find in physics that and this is why this is a really important question. I mean, again, the answer to Lakshmi's question is like basically displacement is always negative when the object moves left in this problem. But the reason I have to elaborate on that, so like it's her first choice in her question is the answer. But the reason I have to elaborate is not just to praise her for noticing this issue, but I have to elaborate because the fact is it is not a law that displacement It is a law that negative has to mean a particular direction. It is not a law that that direction for all time has to be to the left. It has to be consistent with whatever choice we make at the beginning of an experiment or the beginning of solving a problem. We're going to always choose to label a particular coordinate system. As our life becomes two-dimensional and then three-dimensional, this will become more important and possibly more confusing. But we always start everything by choosing to label a certain direction negative and the opposite direction positive, or the other way around. We always choose a positive direction, and then the other direction will become negative. Let me say one last time. It's always a choice, and then we just stay consistent with that choice. So it's always a choice, and the choice will differ from problem to problem or situation to situation, but we have no choice other than to make that choice. Like, it's not like voting. We can't vote to not vote, or it's not like Imposter or Among Us or something. You can't skip vote. Like, you have to make this choice, which is why it's like a really important question. But yeah, from here on in this problem, anything that goes left in this problem, on this number line, on this label coordinate system, is going to be considered negative. That is correct. And even if something turns around, like if it turns around and starts going the opposite way, but like to the right, then that opposite we're going to call positive, not negative. So like, so I hope that answers the question. But really good question. Now, also, somebody wrote in the chat, it is a private, so I'm not going to say the person's name. And it's a very fair, also important question, but I have to be a little bit more delicate about it. Someone wrote in the private chat that on their homework, I wrote, actually, I'm going to write this. Hold on a second. Okay, just to wrap up, what I'm literally saying to Lakshmi's, again, very good question, is we always have to start off any problem, experiment, solution theory with a choice of coordinate system. Right now, our coordinate system is very simple. It's just one axis. Like right now, we're in one dimension. Our coordinate system is literally just an x-axis or a, whatever you want to call it, axis. But by choosing it, what we really are doing is we're saying, where is zero? And we're saying, what are we calling the right side of zero or one side of zero? And what are we calling the other? We must always do that first. So why am I saying that? Because then this other question in the chat. Okay, so I just wrote here's what's in the chat. Now, this is a very valid question. It's like very important. I do write these like 3-letter acronyms on people's homework. You do need to know what they mean in order to read my handwriting and like revise the homework. So I would like to briefly answer, but let me also just tell everybody, like, I think the very last class, I spent a long time trying to explain what all those acronyms were. This is not a criticism. I'm just like alerting you. I believe that the PDF of notes from the very last class, from last Monday, and maybe certain people weren't here or whatever, but so in other words, September 13th, the PDF of notes has all the acronyms explained kind of at length and defined there. Also, therefore, the YouTube video of that class, I spent the whole first of the class, half class explaining. Now, it always takes everybody more than one time to get anything. So I'm not saying this as a criticism, but I'm not going to re-explain all of them right now. I'll try to quickly remind you of what these 3 acronyms mean, because you do need to know. But please, for like more elaborate or expansion, or if you ever want to know again in the future, of course you do need to know. So please refer to the PDF of notes from September 13th and or the YouTube video, and or please someone tell me if I'm wrong and those aren't there. I will try to make a typewritten sheet of this. I've just never have done that for some reason. I will try when I can to put together a simple typewritten sheet, but But the fast answer is, and there's an order for these acronyms. Like it's a step-by-step process that I think everybody should go through when solving problems. It's a 5-step process for solving problems. And often you can get the right answer, but if you don't go through those steps, like I take off points, at least until you do them. Similarly, as long as you do go through the steps, even if you get the wrong answer, I'll give you full credit. So you do want to know these steps. It's like a scientific method for solving problems. And the first step is DFP. So I hope everybody's listening now. DFP stands for diagram and fact pattern. Like the very first thing you should do when you're solving a problem, any homework, even if you think it's easy, especially if you think it's easy, because then this will help you when it's hard. The very first step you should do when solving a problem, DFP, is draw a diagram and give me the fact pattern, i.e. the givens, the assumptions, whatever the givens are. So you should always put a diagram first, even if I put a diagram, like if I put a diagram in the homework, for some people, that's a good reminder for them to put. Other people think, well, he already gave the diagram, so why do I have to do it again? But sometimes I do and sometimes I don't. Sometimes it helps remind people. Other people, it makes them feel redundant. You got to put a diagram no matter what. And one of the reasons you got to put a diagram is so that you can label everything in the diagram. You can label what direction is plus, what direction is minus. By the way, just for the record, this whole number line problem, any one of you, if you had wanted, say you're lefty, like I happen to be a righty, my father's a lefty, say you were a lefty, you could totally redo this whole problem. You could make the right side all negative numbers and the left side all negative numbers, and you'll get still ultimately all the right answers as long as you're internally consistent. So it is a choice thing. And the purpose of the diagram is to show what choice you've made. So anyway, DFP means diagram fact pattern. First, please include a diagram and the givens of the problem. And often the givens are just embodied in the labels of that diagram. So that's what DFP stands for. GDP stands for, sorry, I'm getting myself, oh, I know why I'm confused. After DFP, oh, sorry, someone's coming in. So here, okay, I'm gonna just write this quick. 1 second. Again, please note that what I'm briefly summarizing right now, quickly summarizing, all of this is more expanded on in the notes from last class and the YouTube video from last class, but just so you, okay. So, oh, 1 second, sorry. Thank you very much. Thank you. Have a good one. Okay. There are other comments I make too. Again, just for everybody, I believe it takes everybody more than one time to hear something to really get it, whatever. So like www is one of the comments I do put in the homework. Oh my God. Oh no, my stylus just broke. That's never happened before. I don't know what's going to happen now. Did not see that coming. Well, anyway, www, I'll explain in a second, but the 5, oh, that's really frustrating. Sorry. The 5 steps of any problem solving method in this class and Physics 204 are DFP, WIQ, GDP, PAW, FAC. What do they stand for? Very briefly, DFP is diagram and fact pattern. I just explained that. Step number 2 is WIQ. What is the question? Like you've got to then state you've got to make it clear what the actual question is in your own words. Then 3, general definitions and principles. So once you put the question, like what is the velocity, then you instead of jumping straight to numbers or something, you give a general definition or a principle for what average velocity is defined to be. Average velocity is displacement over time. Like you put that, like in other words, triple equal signs. Then number 4, then particular application and work. After you've put the general principle, the triple equal sign for what average velocity is, if that's what you're solving for, then you write like, oh, then you start subbing in values. Okay, in this case, displacement is -3 meters. In this case, time is 4 seconds. So the average velocity, double equal sign in this case, is -3/4. Then 5 is, so that's PAW, particular application and work. 5 is FAC, final answer circled. Okay, that's the 5-step method. Again, it's explained more deeply in the last class. But if I ever write other things like WWW, that's a shorthand for what, where, why, or sorry, what, why, where, from. And it basically means there's a lot of steps missing, probably like 3 or so of those 5 that I just listed, that there's a lot more work that you have to put down, that you just put down an equation that might be true, but I don't know where it came from or why it applies here or how you're using it. That's what WW stands for. Okay, so sorry to take so long on that, but very important for everybody. That's how I mark homeworks, and that's what you're ultimately looking to do on your exams when we get there, which is not yet. Okay, so that's, oh, okay, thank you. Oh, okay, I totally appreciate that. Okay, thank you for closing the loop, private chat person, totally appreciate that. Okay, all right, so that's that. So now, going back to the actual homework, and I'm still freaking out because my stylus is now oh my God, my stylus is a disaster. What am I gonna do? Hold on, this is actually a problem because I can't, hold on. I'm really, bear with, all right, I literally have to MacGyver this. I'm very sorry. Can everybody hold on for one? I'm gonna go get Scotch tape. This is so sad. 1 second. But we're about, Jerry, you'd think a physicist would have a solution to an electronic problem that was deeper than a piece of Scotch tape. Well, maybe you wouldn't think that. I would wish that. And again, while I'm stalling, while I'm just Scotch taping this, I highly recommend the YouTuber Gus Johnson. He's hilarious. My 17-year-old son introduced me to him. He's very funny, and he does a satire. He does lots of satires, and one of them is like how to be a professor. And he totally mocks the bejeebers out of professors, and particularly shows like a professor like trying to navigate electronic equipment, and not even electronic, like just like a computer and the internet in front of his whole class. And it's so embarrassing, and it's so completely right on. Okay, all right, I think this might have worked. So we're gonna go, yes, it worked. All right, so we're back to the sheet to so we're now doing okay. So now question 3. And by the way, I've already included, I've done my diagram and my fact pattern, presumably at the beginning of this homework. I'm not saying you have to do it every single time for every part. Like the diagram and the fact pattern has not changed. So we drew it at the beginning. And if there's any doubt, you can keep I'll even say here, since it's been days, refer to previous page for a diagram. And givens. But so I've done that, right? So now what is the question? The question for 3 is, what's the instructor's average speed as he moves from -2 to 4? Average speed is kind of the informal English concept on which we're building this more rigorous physics. So there's no actual like symbols really or equation for average speed. I'm just going to leave it in English from t equals 3 2t equals 5. Right, so this is the question, right? From t equals, oh, this is so bad. This is the question from t equals 3 to t equals 5. What's the average speed? So note, again, and I'm sure many of you got the answer really fast. I'm sure this is not a very hard question for many of you. I'm sure I'm boring many of you to tears, but just again, for procedure, for processes, what do I do now? Instead of just writing down the answer, I write, first of all, I write like this is, so this is now, so that was step 2. That was, what is the question? Just so you know, right? That was, what is the question? Now I'm doing general definitions and principles. That is, before I rush to a number, even if I think I know, I'm going to say average speed equals triple equal sign total distance over total time. It's like what many of you might say, write down the formula first. I don't believe in the word formula. You'll see why as we go more and more. But yes, write down the definition first, and notice that it's a definition by the fact that it's a triple equal sign. And why do I write the definition first? Well, 1, because it's going to help me, but 2, because definitions are always true. So even if I don't know what to do next, or even if I'm not sure of the numbers, this is, if this were an exam right now, I would get points for writing that down. Even if it were irrelevant, it's true. It's not wrong. But anyway, whatever. Now I can say here, the distance we just got in part 1, the distance is 6 feet and the time is 2 seconds, right? I mean, I know this is all obvious to many of you. So what I'm doing here, well, I'm turning the page. Well, so this process that I'm doing now, the part that many of you would consider the work, I'm saying is just a specific piece of the work. This is the particular application in work, what I'm calling PAW, right? So that's like step 4 of the process, step 2, step 3, step 4. And then I'm going to the next page, I'm reducing the fraction, which, just to make it clear, so I'm getting that the average speed equals 3 feet per second. And that's my final answer. Right, my final answer, totally circled, highlighted, blah, blah, blah. That is my final answer. And so I'm done. So I think that's the answer to that one. The average speed is 3 feet per second. Now I want to start moving a little faster, right? I want to start making a little bit more tracks. And I think I'm probably boring some of you. God knows I can't live with that. So if now we're on part 2, question 4. I'm going to start skipping steps, and I'm going to make that clear. Like, you know, at times now I'm going to skip steps because I just want to get to the answer for you, because I think you get the point of how to do this. You should stop me if you have any questions. I don't want to confuse anybody. Like, in other words, if I'm going to start skipping steps, I'm not saying this is how you should do the homework. I'm saying, okay, I trust you and you trust me. Let me start just making sure that you have the right answers. So also, my stylus is a disaster. Okay, and I feel a little bit hypocritical doing this, but you know, this is why it's class, not always life or recitation. Like, I do just want to start moving on a little bit. So part 2 question, I hope that's clear. So in part 2, question 4, and you can tell me to move back if you want. In part 2, question 4, like we want average velocity now. I'm going to skip straight to the GDP, the general definition and principle. And I can do it symbolically now, because for average velocity and for displacement and position, all that, we have symbols like average velocity equals displacement over time, right? Again, if we're still getting used to this, just note, like, it's technically this, right? It really is just displacement. It's like difference in positions over position, excuse me. It's difference in positions over difference in instance. Like, it is a totally symmetric definition. It's just that T sub 0 always equals 0. So we never have to write it. So that's why I start leaving it out. But so in this case, so it is the same answer as before. It's not the same question, but it is the same answer because oh, this goes all the way back now to Lakshmi's question. Because the thing happens to be moving right, all in this case, all of the displacement and velocity answers are the same as all the distance and speed answers. If this thing happened to be moving left, I mean, this really probably was Lakshmi's question. If for this entire interval, the thing happened to be moving left, then the distance and the average speed answers would be the same as what we got. We would get like +6 and +3 feet per second for distance and average speed. But for displacement and average velocity, we'd be getting -6 and -3 feet per second. It just happens to be moving to the right, not to the left. I think that was probably Lakshmi's real point. Okay, so we did that. That was question 4. I'm going to put another Scotch tape on the stylus. This is such a disaster. I mean, disaster. I mean, the world is about to fall apart in this stylus. I'm not kidding. Okay. So the next question is, okay, yeah, I'm going to skip. All right, question 5. What's the instructor's average speed? So I'm going to skip steps again. Like, I'm just going to go straight to it. We want, like, so we want, well, I'm going to skip some. Now in the final, I believe it's 9. Right, so I believe, so in the last 3 seconds of his journey, he goes all the way from -5 all the way to +4. How do I know that? By the way, just because it was told to me in the givens, like at the beginning of the problem, I was just told that you might want to write that like given. But how do, and it's the final 3 seconds because the problem says final 3 seconds. So stop me if I'm wrong, but I believe it's a distance of 9 feet over 3 seconds. Now, again, kind of an unfortunate coincidence here that we happen to be moving right. So it's not really showing a distinction between displacement and distance, but it is what it is. Come on. So then this is. So here. Now we're talking velocity, so we can use symbols here. But again, it's Okay, I don't have too much to say about this. Please stop me if there's a question, but I think the answer is the same. Again, I don't know if it's that fascinating a question, but it is what it is. The average velocity during the final 3 seconds is a displacement of positive 9 feet divided by a time interval of 3 seconds. So it's 3 feet per second. That's part 2. Again, I'm just going to keep going, but please stop me if there's any questions. This goes to level 5. Okay, we're starting to make tracks here. All right, so then, problems in which you must think. That's intimidating. Okay, so what are the next thing? So, okay, part. Okay, so now we want to know at the 7th second, what is the instructor's position, right? That's the question. At t equals 7, what's the position? Again, this diagram and the fact pattern are still the same, but that's the question. Now, I think we do have to think about that for a minute. I think this whole journey takes 8 seconds, right? Yeah. Oh, have I been saying this right? Yeah. So I'll say this. I think the answer is x equals positive 1. I mean, just to get that out of the way, I think the answer is going to be x equals positive 1, like 1 foot. So if you got that answer, then you know what you're doing, and that's great. And then everything I'm about to say might be boring to you. If you didn't get that, so I don't know, get a cup of coffee, whatever. You still have to show work, but blah, blah, blah. I do think the answer is 1. If you didn't get the answer of 1, that you really might want to pay attention to what I'm about to do. But I also just want to say, notice how part 3 says problems in which you must think. Like, I do think no matter who you are, whether you got this one right or wrong, and again, I'm just saying, I think the answer is positive 1 foot. I'm not writing it yet because I didn't get it. I do think the answer is 1 foot. I think, though, no matter who you are, whether you got that right or wrong, even if you got it right and you got it very fast, I think it's hard to disagree that you had to do a little bit more thinking to get that one than the questions prior to it. Like, that doesn't mean it's hard or easy. I don't even like those words anyway. Like, everything is easy after you do it, and everything is hard before you do it, right? Like, hard and easy don't mean anything, and they just like upset people when we like. I hate it when people say something is easy in front of my 7-year-old son or my 17-year-old son. Like, it just sets them up for failure. Anyway, whatever. I hate those words, but I will say, I think it's fair to say that this question, part 3, question 1, even if you got it right, like, I do think you had to do more steps mentally in order to get this question right. Like, that's really all we mean when we say problems in which you must think. Like, okay, we had to think to do all of this, but you had to. Your brain, no matter how smart you are or how comfortable with physics you are, your brain has to do at least one more step to get this question right than it did in all the previous questions. Because it's that much more complicated. There's at least one more step to do. So again, if you did get it right, praise yourself, give yourself credit. Don't be like, duh, I mean, it said you had to think, but I didn't really have to think. Like, it's not that big of a deal, yo. Like, it is a slightly bigger deal than what you did in parts 1 and 2. There is an extra step. You'll see that if you write down all the steps that your brain went through. Now, again, your brain might go through them very fast, but don't use that fact don't use your own arrogance as an opportunity to insult yourself, if that makes any sense, or whatever. Like, don't insult the problem or yourself. Your brain, no matter who you are, had to do at least one more step in order to do this problem. So what we're doing, just because the problem is that much more of an extrapolation, it's not a direct question, it's an indirect question. It's based on the facts, but the facts have to be combined in a certain way in order to get the answer, no matter who we are. So if we can do those steps very quickly, we can feel good about ourselves, and we should. But that's all the more reason we should be capable of making a record of what those steps were, like actually putting the steps down on paper. It actually right? I mean, and I know I'm saying this to all of us. Like whenever I do know something, it drives me crazy when someone asks me to show my work because I'm like, what? Are you challenging me? What? Are you saying I cheated? But no, they're saying, show me what your brain did. Slow down the movie, please, so that we have a record for next time when our brain doesn't know what to do. Like, honestly, I cannot praise that enough. I mean, I cannot emphasize that enough. It's what all physics is record keeping on what you do when you're not feeling so challenged, so that you have something to do when you are feeling challenged. So that's what we're, and by the way, if you didn't get this one right, don't feel bad at all. Please, it is one step more complicated than the steps before it. But also then don't take it out on me or on the sheet. What I'm going to show you now in the record of what we did, or maybe you'll show me if you want in the chat. It will take one or two more steps, but that's all they are, is steps. Like it doesn't take any new outside information that wasn't presented in the problem. It doesn't require some new formula that nobody learned or something. That's the flip side of physics. Everything we're doing should be based on something we did before. It should never be black magic. It should never just be, and this is why I don't like the word formula. It should never be just like, oh, like magical recipe that we found in a textbook that we now just like know, like spontaneously to pull out because we feel like it. It's always supposed to be based on logic and definitions, i.e. whatever equations we already have, we might rearrange one algebraically to get this right, but that's just logically inferring from the equation. We're not going to invent anything new. Okay, that's all a long way of saying. So what do I do here for where's the instructor? This is what I do. I say, well, I don't know, like I start with a general, so I start always like, so that was the question, right? So now I don't know what to do. Like, I don't know what position he was at. And I might even think to myself, wait, Averagevelocity never gave me a formula for position. Like, I don't know any equation for like finding position or something like that. Like, what am I supposed to do? I might start randomly plugging in numbers, but I shouldn't do that. I should always go to general definitions and principles first. Whatever general definitions and principles I have that are true, I will then tweak them to try to apply them and make them relevant. You don't start with what's relevant and try to make it true. You start with what's true and you try to make it relevant. In other words, I'm going to write down the one thing I know, like the one equation I have or whatever, which is just definition. I'm going to write this down, right? The same thing I've been writing. Notice I'm just writing the same thing that I wrote for every question prior to it, every velocity question. I write average velocity equals displacement over time, right? Now I can now before I start plugging in numbers, I note to myself, aha, like in this case, what I'm solving for is something different. I'm looking for a position. And that's what I'm looking for this time. So I'll rearrange. I'll go like this. Right. And it's still, I don't know what that's a triple equal sign or double equal sign. Notice now what I've written down there, it's not a new equation. I'm not pulling something out of a bag. It's not a new formula. It's just a logical rearrangement of an equation that I already had. If you read this in English, it's almost now it's saying displacement. Well, I mean, if the other equation is always true, then this one has to be always true because it's just algebra, right? But this is what people, when you often hear, this might look unfamiliar mathematically, but it's what people always say in English in a way. People are always like, distance equals rate times time. They mean this. Distance doesn't actually always rate times time. Distance equals a particular rate called average speed times time. In other words, distance does not equal rate of acceleration times time, and distance doesn't even equal rate of velocity times time. Distance equals average speed times time. Similarly, displacement equals average velocity times time. That's what this is saying here. Or put another way, final position minus initial position. And again, I know I'm dragging this out. Please forgive me. I'm just trying to show you that this is going to happen a lot in physics. We're going to have an equation that we believe in, then we're just going to rearrange it as at our convenience. We're just going to expect that we can do that. We're not going to like look up on a list and see if we have both equations on the list or something. So I'm just saying in English, final position minus initial position equals average velocity times time. I'm just translating that so you can have perspective on it. But to go back to the math that I'm solving for here, so we have this. Now, what am I solving for? I'm solving for final position. Notice I just did a lot. Now, your brain might have done this very fast. You might not have written down all these steps. You might think this is overkill, but just please do notice I'm able to write all these truths down without plugging in one number yet. I haven't plugged in one number, and that is a habit that I want you guys to get into. Save the numbers for last. The harder the problem is, the more important a habit this is, and especially in Physics 204. Save the numbers for last. I'm just rearranging and rearranging until I can get a statement of general truth that applies to my problem. Like what I now have is a statement that's generally true. X equals VT plus X naught. You could actually look that up in some books and it'll tell you that that's an equation or a formula. I think that's dumb. Like, don't memorize this as a different equation or something. It's literally just the old truth rearranged, but it is as true, I should say. It's as true as average velocity is defined to be displacement over time. That is, this is always true. Always, always. So if I were in the middle of an exam now, I could not have lost any points for doing all of this. Like if I did it carefully, it is totally right, even if I've lost sight of what the actual problem is here. Now I can plug in numbers, right? And I could say this. Now, I'll let you read that one. Pardon me for 1 second. Pardon me. Okay. Now, again, I think, oh, wait, there's something in the chat. I'm sorry, chat. Oh, wait a minute. Okay, very good question. Very good question in the direct chat. It's in the direct chat. I'm not going to say the name. I'm going to warn you too. Again, this is a fantastic question. And I'm going to read it out loud in a second without saying the person's name, but I'm also going to say, and I've got to make a portal for this. I'm going to warn in advance that my answer to this question happens to be no. Well, all right, let me say the question. So the question, but it's still a great question. And it wouldn't be any greater if my answer happened to be yes. This is like a funny thing that happens to science. So let me just read the question. I'm not reading the person's name, but I'm really glad this person asked this. And I would be glad no matter what the answer was. The person asked, isn't the unit for velocity feet per second squared? Now, that is not a crazy question. Not at all. First of all, but the answer is no, it's not. And I know what the person's thinking, though. I'm going to say this. Let me first say that it's really cool that people are worrying about units. We should be worried about units. You should be tracking my units and making sure that I'm being careful about them. And you should have the guts to correct me or point out when you think I might have made a mistake, because I definitely do make mistakes, or if you think you're confused. Now, and so the person said, aren't the units for velocity feet per second squared? They are not crazy for asking that at all, because the units for something in physics are feet per second squared. But that's acceleration. That's what the person's thinking of. Like it, and we're going to get to that. It is true that the units for acceleration are feet per second squared, or if you like, meters per second squared, or miles per second, kilometers per second squared, or minutes squared. But there are motions where the units are space per time squared, but that's acceleration. And the reason for that is acceleration is change in velocity per time. So if you have a velocity of like if you think of your car, if your car is going 10 miles an hour now, and then an hour later, it's going 20 miles an hour. So it raised its velocity by 10 miles per hour within that hour. You could say on average, it's changing its velocity by 10 miles per hour. Like it's changing its velocity by 10 miles per hour every hour. So we could say miles per hour. In other words, miles in the numerator and hours both in the denominator, miles per hour. And so then we abbreviate that, or we multiply them together and we say miles per hour squared. Like there definitely is a thing in physics where the unit of a certain thing is like feet per second squared or miles per hour squared, but that thing is acceleration. And the reason I'm so glad this question was raised is we are going to get to that, and we do have to deal with feet per second squared, but velocity is just velocity. Velocity is just feet per second. The other reason I'm really pleased with this is people all the time confuse because we're progressing in this course. We went from average speed and then we're going to velocity. It almost sounds, since we're progressing, it almost sounds like, oh, there's speed. I understand speed is like miles per hour. And then it's easy to think, oh, I guess velocity is like the next thing, like the change in speed, like miles per hour per hour. But no, velocity is just speed with direction taken into account. Velocity, if speed is distance over time, velocity is displacement over time. Velocity is still just a rate, or just a regular everyday rate in time, just happens to be one that takes into account direction. So the next, in other words, velocity is the first derivative of position with respect to time, if you're thinking in calculus terms. Then acceleration is the derivative of that. So displacements are in meters, velocities are in meters per second, accelerations are in meters per second squared, or feet, or whatever. It's a great question, and I'm going to say one more time now to everybody. It happened. So the person asked, are the units feet per second squared? I'm saying no. So you might say, oh, so then the person was wrong. That doesn't, but it was a question, right? Like, are the units this or that? So whether I said right or wrong, it's still total information. And actually, this person is bringing up a confusion that people have all the time, but most people don't even know that they have the confusion. They don't have the guts to even realize themselves or to bring up to me that they're confusing velocity and acceleration. If there's any chance any of us is going to keep speed, velocity, and acceleration straight, the only chance we're going to keep them straight is if we admit actually that they're easy to confuse and if we drum in the distinction. So I'm extremely glad that someone asked this question. It doesn't matter that my answer happens to be no. That doesn't change the question. I do want to give that person reports. I'm going to figure out how, blah, blah, blah. I kind of hope if I did answer it, I hope they'd tell me in the chat if I answered it or whatever. And I don't want to make too big of a deal of it. But I want to encourage everybody to ask these kind of questions. Like, okay, thank you. Cool. Thank you. I totally appreciate it. All right. But yeah, like, okay, side note too, now this is not about the person. It's not about the question anymore. But a funny side note thing is I give true false exams sometimes, or pieces of exams that are true false, particularly in 204. And I don't try to make them tricky anymore. They're just like hard on their own. But I used to have this thing at John Jay. This is a really funny thing where I would ask a true false question. I mean, this is before COVID, but I would ask a true false question, and people at John Jay would sometimes come up to me in the middle of the exam with the true false thing. So like maybe I would write, for example, I might write true or false, average speed is never, sorry. I would write something like true or false, the average velocity for a trip could never be smaller than the average speed. Okay. And by the way, think about that for a minute, like good little review question here. I'm going to say it again. You can answer in the chat if you want for points, but I'm just going to say, there's a side note, little practice, little review. If I wrote true or false for a given experiment, the average velocity could never be smaller than the average speed, right? I'm going to say it one more time, so hopefully everybody's paying attention, just for practice. Imagine if I said true or false, the average velocity for a given experiment could never be smaller than the average speed, right? If anybody wants to, they can put an answer in the private chat or in the public chat, or just to let me, or you don't have to, but hopefully people are thinking about that for a minute. I'm going to just pause for a second if anybody wants to. Okay, maybe I won't pause too. Or if anybody can even put in the private or public chat, just like, I hear the question and I have an answer. You don't have to tell me your answer if you're afraid, but just to acknowledge if you all hear it. So I'm going to say it one more time. I think it's worth thinking about. True or false, for a given experiment, the average velocity could never be smaller than the average speed. Okay, cool. Oh, I'm particularly Jayla. Awesome. Okay, so Jayla, I think and that's what I'm looking for. So she just said she thinks she has an answer, which tells me that she hears the question. So she doesn't have to go on a limb. I don't ever have to know whether her answer is right or wrong. I totally appreciate that Jayla just did that. That is total points. I don't know if anybody else wants to do that too. Just cool. Oh, thank you, Alyssa. That's awesome. Okay, and I love. I don't know why I'm laughing. But I know everybody hates being wrong in public. Believe me, I hate being wrong in public. Okay, so two people have an answer. All right, now I'm going to tell everybody here, and hopefully you heard the question again. The question was true or false, for a given experiment, the average velocity could never be smaller than the average speed. So here's the answer. The answer is false. It totally could be. Okay, the answer is the average velocity could be smaller than the average speed for a given experiment. For example, and I think there was an example in this sheet, anytime someone does a round trip, right? If someone and they do in this sheet, they start at +4, they go all the way to a -5, and then they come back to +4, at least in the first 5 seconds they do, right? For the first 5 seconds of this whole sheet, of this whole homework, the instructor goes all the way to the left, like 9 feet to the left, and then comes back 9 feet to the right. So the average speed for that is some big number. Like the average speed for that actually is 18/10, I believe, like 9 plus 9 makes 18 feet over, sorry, 18/5. It does all of that in 5 seconds, right? So it's 18/5. And I guess I feel like, did we ever get that answer before? So that's like 3.6 feet per second, unless I'm forgetting something. That's the average speed. But the average velocity definitely for that round trip is 0, right? Because the full displacement it's first -9, but then it's +9. The full displacement is 0, as it is for any round trip. You end up where you start, then you were not displaced. Your final position minus your initial position is 0. So just for that example, right, for a round trip, your average speed is some big number. Maybe I did the number wrong in my head a second ago, but the average velocity is definitely 0. So average velocity most certainly can be smaller than average speed for a given trip. In fact, if you really think it through, you'll see that, in fact, for all trips, average velocity must be less than or equal to average speed. It's never going to be greater. It might be the same, or it might be less than, and it might be a lot less than, because average velocity might be negative and average speed is never negative, right? So first of all, hopefully it's a little review for everybody. Like for any given experiment, the average velocity is equal to or less than the average speed. It's never greater than. Now, as a side note, the why I'm bringing it all up, if I write that on a true false question, if I write true or false, average velocity is never less than the average speed for a given trip, The answer is false because it sometimes is, right? Maybe that's a little bit confusing. Maybe it's a little bit of double negative, but I hope you'll agree and admit it is a direct question. It's not like convoluted. It's just a little bit funky in the way that true falses always are. And here's the thing that often happens at John Jay. When I've written questions like that as true false, people will come up to me in the middle of exams and they'll like parse the question out and they'll actually get the physics and they'll understand the whole thing and they'll be sitting in their head thinking like, wait, he wrote never smaller than, but it can be smaller than, because like, what if it's a round trip? So people will come up to me and they'll be like, I'm totally confused by this question. And I'll say, why? And they'll say, well, I don't get it. I mean, like, if you're a round trip, the thing could be smaller, right? And I'm like, yeah, that sounds right to me. So what's the problem? And they're like, well, that's totally confusing because the thing says never then, but like it could be. And I'm like, that's why the answer is false, right? I mean, I don't say that in the exam, but there's this weird way in which if you get a true false question, but the answer is false, a lot of times, for some strange reason, if the answer is false, our brains can't handle the fact that that's a legitimate option. We're so used to like reading things and wanting them to be true that like, if the thing is false, we don't just think, oh, so the answer is false. We're like, I must not be getting something. This is like a totally confusing question. Like, what's going on here? If it had been true, I would understand it, but it's false, so I don't get it. Even though it's like, well, it's a true false question. I mean, it's one or the other, like pick. And apparently if you don't buy it, you must not buy it. So you think it's false. Why am I saying all that? I'm saying all that to say like a lot of times really legitimate questions are asked in a class if we have the guts, but people sort of feel like they're only legitimate if the answer is yes, but they're just as legitimate if the answer is no, just so you know. Okay, I'm going to move on. Okay. Oh, so now what am I doing in this problem? I haven't gotten an answer to this problem yet because I'm just babbling. It's metaphysics with the Averbound. I'm going to get an answer here. I'm about to show I'm about to plug in. Well, all right, I'll plug in the numbers and I'll get the answer that I'm saying, but then I'm going to back up because you might not have done this way, or you might sort of have done this way in your head, but you don't see what I'm doing, or blah, blah, blah. Here's my numbers. Now I can plug in. So you notice the units do cancel. All right. So number one, I'm saying the answer to this question that I just dragged out is +1 foot. That's a position. The final position where the dude ends up is the position X equals +1. I did it by just rearranging an equation, a definition that we already had. I didn't make up a new equation. But I did do what I expect that we're all capable of doing. I took an old equation and I rearranged it. And frankly, there's one of the reasons I say this question took a little more thought than the others. I don't think it's unfair. I don't think it's asking us to do. Oh, sorry. Oh, 1 second, sorry. I'm like a defensive guy, right? I just want to make clear. I think this question took a little more work. I mean, it took me definitely more steps, and I'm dragging everything out to the maximum number of steps, but I did drag out all the other questions, or most of them, to the maximum number of steps too. And it wasn't as many steps as this, right? Also, there's a decision I made in one of these steps that I still think I have to justify to some of you. So I think there's no question that this question takes more work than the others, whether we got it right or wrong. On the one hand, I want to say, therefore, that even if you got it right, you should still praise yourself and recognize, even if you got it right, that doesn't mean it was a joke. Like, you had to do something to get it right. On the other hand, if you didn't get it right, you got it wrong, don't say it was unfair, please. Like, or don't say, well, that's impossible. How was I supposed to know that I had to do all that? Or how did he expect me to do all that? Because if you follow, and the answer is this, if you follow the 5-point problem solving procedure, if you just always go first with the diagram and givens, then with the what is the question, and then you actually write down a general principle or definition, and then you try to apply that general principle to the problem. It all sounds obvious until you get to a problem that's hard, and then you realize that people don't do this actually, but they should. If you do that, you can see that's all we did here. The truth is we only have one equation in our arsenal so far. Honestly, like we literally only have one actual equation in our arsenal. That means it would be unfair for me to ask us to do anything that can't ultimately be done with that one equation. And that is the story. Everything we're doing right now can be done with one equation because that's all we know. But it might require some manipulations and some real unpacking of that equation or some real appreciation of how deep that equation goes. Of course, we're going to get other equations too. But I want to warn you now that the other equations we're going to get are just also going to be definitions. They're going to seem really obvious at first, I hope. They're going to seem like they're not even knowledge. You're going to be like, that's like not an equation. That's just like duh. But if you take them really seriously, you start seeing how there's a lot of fruit that comes out of these does. And that's all equations should ever be in physics. It's something that starts off as like a duh, I knew that. But what we didn't know was how powerful an insight it is, okay? So I just rearranged our old equation. I didn't introduce any new knowledge or any new formulas or anything, but also I made a decision. Now I'm gonna go, this now goes back to, I believe it was Lakshmi's original question. I believe it might've been Jayla's. I think it was Lakshmi's original question. No, and again, this applies to those of you who got this right and maybe even don't know why, or just like did something fast in your, and let me say again too, if you just did something fast in your head and you got it right, you might be thinking, well, I did it a different way. Is that okay? I'm actually, and yes, always in physics, if you do something a different way, but still get the right answer, and it wasn't a coincidence, then cool, I want to see the different ways. And as we get more and more advanced, there are more and more different ways to do things. But I also want to encourage you to realize that a lot of times people think they're doing something differently and they're not. They're just doing it faster, so fast, and they're so smart, they don't even really know what they did, maybe. Like you might have just visualized this and got the right answer. Kudos to you, but then show me the visualization or realize, and here's what realize that if you got the right answer, in effect, you realize that once you know the average velocity for a segment, then you're sort of in your mind doing distance equals rate times time. You're saying, oh, good, I have a rate now, so I can extrapolate from that rate to where something is. But if you did that in your mind or on paper, I'm going back a page now, notice this. We can get where the dude is or the dudette is because we know how fast, oh, and I know class ends in 3 minutes is the last thing I'm going to do, and then we'll call it today. And I didn't get to this second sheet, but that's on me. If we can get where this person was at t equals 7 entirely and only because we know how fast the person was moving during a segment of time that included t equals 7, the way to get this right, no matter what you did, you had to at some level at least visualize in your mind, if not write down, that the person was advancing at a rate of 3 feet every second. Like you, in order to know that he landed at the 1 foot mark at the 7th second mark, there's no way to know that unless somewhere in your brain, somehow you understand that during that time, he's advancing, she's advancing 3 feet every second, right? Which is why I wrote down this fact that we had not coincidentally figured out a couple of questions earlier. We know that every second the thing is moving to the right 3 feet. But now here's my point. That's true, and that's crucial information. And it's true at the moment that we're interested in at t equals 7. But it's not true everywhere in the problem, right? Like the average velocity is not 3 feet per second everywhere in the problem. At some point, it's negative. At some points during the problem, the thing is going to the left, as Lakshmi originally pointed out. And at other times, the thing is going to the right, but at a different rate. So now to be consistent, if we're going to use the fact, whether it's in our head or in a picture or in an equation, if we're going to use the fact that every second, if we're going to rely on this consistent pattern known as an average velocity, that every second the thing is advancing to the right by 3 feet, we can only use that fact when it's actually true. It's only true for the last 3 seconds of the experiment. So I zoomed in, right, tacitly, what's going on here? I made a decision to zoom in on the last 3 seconds of the experiment. In other words, I redefined the experiment. I started my clock ticking, my paying attention clock, at t equals 5, right? And I just looked at those last 3 seconds because the velocity changed for the other segments. This wouldn't be valid for the other segments. So I just looked at that last segment where he's advancing 3 feet per second, and I see the time, I'm about to stop. At the beginning of that second, the initial position for that segment, for the last bit, right? The initial position for that was -5. Like, where did I get this -5? It's -5 at t equals 5, right? It's not -5. That's not the initial position for the whole entire experiment. It's the initial position for the interval that I am choosing to examine right now. And I know class is just about over, but this all goes back to the Lakshmi thing. Now notice I make a choice. I'm going to start my stopwatch at t equals 5. At that moment, I think it's 5. Yeah. At that moment, the instructor is at the position -5, and then I let my clock go all the way to t equals 7, right? So I'm looking at that last bit. So I just go from t equals 5, t equals 7. That's why I wrote down t equals 2. In other words, these 3 numbers were not given in the problem. They are the 3 numbers that correspond consistently to the last bit that I deliberately choose to look at, because that's the bit that I have an average velocity for. Once I do that, then it is just plug and chug. The plug and chug is easy, but the setting up the plug and chug is the issue, always in physics. And the way to set up properly is to do the 5-step method that I'm trying to teach. Sorry, I didn't. So that's it for today. I know we're totally done. Sorry, I went over time. We'll get to homework 2 next time. I promise. Just keep on keeping on. You don't have to do anything new. You can please go. I'm just going to stop if there's any questions, like, quickly right now. So I'm here, but please go. Thank you very much.